at designscienceassociation@gmail.com. And our speaker this morning, Psarris, was previously an engineer in the United States Military Space Program. That sounds interesting. Again, the U.S. Military Space Program. He entered that program as an atheist and an evolutionist and left as a creationist and a Christian. Even more interesting. And Spike now speaks on creation and Christian apologetics, equipping believers to defend their faith and glorify their Creator. Spike, thank you very much for speaking with us this morning.
Well, thank you all for having me. And I'm told that this will go on automatically. And can we get lights to go down, please? Darker's better. See less of me and more of that. Well, it's my privilege to be here with you this morning, given a lot of the events of the past year or two. I haven't spoken in a while, this topic especially, so looking forward to shaking the cobwebs out and talking about these things again. And I'm thankful also to talk about astronomy and cosmology, because these things sometimes have a kind of stigma to them, unfortunately. I'll talk about that first. The rumor you may have heard is not true. It is not true that excessive stargazing causes you to lose all your hair. So, I don't know where people even get an idea like that, but anyway. So, our topic here this morning, distant starlight. Does it disprove biblical creation? This is a fairly narrow topic to discuss, to spend an entire session on, more so than most creation presentations would be, but it's an important question because this often comes up in the whole discussion of creation, evolution, the Bible versus the Big Bang, and that sort of thing. And it's a fairly straightforward issue. We see light from distant objects, and it takes some time for that light to get here from there. And in the context of biblical creation, where we would affirm that the earth is very young compared to the billions of years claim that is often made, how do we explain the fact that we can still see these objects that are so far away? If light would take such a long time to get here, isn't the fact that we are receiving this light evidence that the universe and the earth are much older than is commonly, or that we would say it is? Well, this all comes down to one equation, time equals distance over speed, and you will see, I'll be referring back to this, and for those of you who are math phobic, this is about as deep as it gets math-wise, so that's good. But it's a fairly straightforward calculation. You take the distance, you divide by the speed, and that tells you how long it takes for something to travel that distance at that speed. And indeed, we do see things that are very far away from us. For example, the Andromeda galaxy is about 2.5 million light years from us, and a light year is the distance that light would travel in 1 year. So 2.5 million light years would indicate that it should take that light 2.5 million years to get here. Yet it has gotten here because we do indeed see this galaxy. And this is actually our next door neighbor in space, relatively speaking. We see objects that, according to our distance calculations, are 13.2 billion light years away. And a billion is 1,000 million, so this is 13,000 million light years away. So a straightforward calculation would seem to indicate that the universe has to be at least 13.2 billion years old, right? Because we can see these things. And if you get involved in the creation versus evolution discussion, you will hear this issue raised a lot. There's actually an entire page on it here on this wiki. And it's often presented as a knockout punch for affirming that the earth is young and that the universe itself would be young as well. And even some Christians have said that this is something that gives them pause in affirming a straightforward interpretation of what the Bible says about origins. Dr. Norman Geisler, for example, no longer with us, but when he was still here, he was a giant among Christian apologists, right, if you're familiar with his work. Brilliant, brilliant man. He did not, however, affirm a young earth creationary view of Scripture. And he said that, I think the speed of light is the crucial thing. If you could prove that the speed of light changes, you'd probably convert me to a young earth creationist. He wasn't a young earth creationist, and he was really hung up on this one issue. How is it that we can see light from these objects so far away from us? Dr. William Lane Craig, another well-known apologist, again, a brilliant man. He is also not a young earth affirmer, though. He said the scientific evidence overwhelmingly supports the idea that the earth is very ancient. Well, why is that? He says, when you think that we can see the stars, that very simple fact, that you can see these stars billions of light years away, shows how ancient the universe is. So it's not only the skeptics and atheists who say this is a problem for affirming the Bible's view of creation, even some Christians, some very well-known and very intelligent apologists, make statements like this. But there's actually more to this issue than only saying we see things that are so far away. What do I mean by that? Well, the nearest star to us, other than our sun, is Proxima Centauri. It's over 4 light years away. Could Adam see any stars when he first awoke in the Garden of Eden? We would say yes, right? Well, if the closest star would still take 4 years, over 4 years, for the light to get here, then that would mean this is not just a billions of years issue, right? There's more to this that we have to explain. Excuse me. And the overall issue here, I'm going to refer to by the abbreviation LTT, standing for light travel time. So why does this matter? Why is this apparent discrepancy between what the Bible says and what we see in space before us? Well, because Adam lived roughly 6,000 years ago, according to Scripture. It doesn't give us a date, of course, as to when Adam lived, but we can add up all the genealogies and figure out that Adam was roughly 6,000 years ago. And the Bible talks about God creating man, creating Adam, in his own image. In the image of God created he him, male and female created he them. When did that happen? Well, when God saw everything he had made, and behold, it was very good. Evening and morning were the 6th day. So on the 6th day of creation was Adam created. And Genesis 1:1 talks about this being in the beginning of everything. Now, sometimes people say, well, maybe there's a long period of time before Adam. God created the heavens and earth, and then billions of years passed, and then Adam and Eve were in the garden, and so that's how we reconcile all of this. Well, that doesn't work, though. Mark chapter 10 says, they said, these are people arguing with Jesus, Moses permitted a man to write a certificate of dismissal and to divorce her. But Jesus said to them, he wrote this commandment for you because of your hard hearts. But at the beginning of creation, God made them male and female. So he's quoting Genesis here. Now, he's arguing about the issue of marriage and divorce, of course. But what is he saying? When were Adam and Eve created, or when was Adam created, at least, according to Jesus? Well, right at the beginning of creation. Not billions of years afterwards, right at the beginning. Plus or minus 6 days, right? Now, would Christ know what he was talking about? Well, yes, John 1 and other places tell us Christ is the creator. So he would certainly know when he created Adam, wouldn't he? So a straightforward view of all this from a biblical perspective would indicate that the earth is roughly 6,000 years old, give or take. Therefore, the fact that we can see things so far away that it would take the light millions or billions of years to get here would seem to discredit Scripture and confirm a secular view of origins. And today, the secular cosmological view is the Big Bang model. So hopefully I've set the stage here for why this issue is important and what the issue is. We can see things that are very far away. Doesn't that discredit a straightforward view of Scripture? Well, no, actually it does not, because this is not a straightforward argument as it's commonly presented. There's a lot of assumptions built into this question, built into the controversy as it's normally posed. Question is, can you spot them? I mean, it seems like such a simple argument, right? Well, as I said, this whole argument is based on this one equation, time equals distance over speed. What assumptions are built into an equation like this? Well, quite a few, as it turns out. For example, let's talk about the speed. This equation assumes that the speed has never changed. The speed of light specifically has never changed all through history. What if the speed of light used to be higher in the past? How would that change the math? Well, it could potentially change it a lot, depending on how different the speed of light used to be. And indeed, in creationist circles, for a number of years, there was a lot of interest in this question. There was an argument based on historical measurements of the speed of light that we can see the speed of light decreasing, which would indicate it used to be higher in the past, potentially much higher. And of course, the higher it used to be in the past, the less time it would have taken for light to travel from there to here. Does that make sense? Now, further investigation into that particular question showed that the historical data wasn't really precise enough to make that argument, and so most creationists today no longer view this as being a viable option. But I want to present it to you this morning for two reasons. Number one, a lot of people have heard of this idea, and number two, it shows a clear example of an assumption that's built into the argument, right? Turns out this isn't the only assumption that's built into the LTT issue. In fact, there's 5 assumptions that I'll be talking about this morning that are being made by the LTT challengers. Those who point fingers and say, you creationists are all washed up, there's clear evidence, right? Just look at the sky. Things have to be billions of years old. They're making at least 5 assumptions, actually more than that, but in my time this morning, I'll be talking about these 5, and showing how questioning each of these assumptions actually opens the door to a different solution for this issue. And in fact, I'm not actually presenting the solution to the LTT issue here this morning. In fact, I'm going to do my best to conceal my personal views on the matter, just to make it more fun. Because this is not about presenting a specific answer. This is showing how the question itself has a lot more facets to it than what people are commonly aware of, and that this is a much deeper and richer issue for us to investigate, and incidentally does not discredit Scripture. As you will see, I'm going to argue that the correct view of this is that it supports creation. So what are these assumptions I'll be talking about? Well, number one is more of from the challenger in this typical discussion. Usually when someone challenges you on this issue, they're assuming that the Big Bang is a valid model and biblical creation is not. So that's the whole framework within which they are presenting this argument. Assumption number 2 that they're making is that the speed of light is constant through space. Assumption 3 is that light has always traveled the entire distance from those objects to us. Assumption 4, light has always traveled as it does today. And assumption 5 is that the universe has no center of mass. What does that have to do with anything? Well, we'll see. So let's talk about these. Assumption 1. Typically when the LTT issue is being discussed, the person raising this argument is coming from a Big Bang viewpoint. They think that secular cosmology, that the Big Bang model has this all figured out, that this person making the argument has a solid scientific foundation to be standing upon, and therefore can point fingers at someone else and challenging them. Well, let's spend a little bit on this, and this is actually going to be a broader discussion, at least for this one point, than only an LTT issue, but you will see later why I'm going into the depth that I'm going to go into. So let's ask the question, is the Big Bang model actually consistent with the universe that we live in? Well, it would need to be if it's going to be a good scientific model, right? The claim is made that there's lots of scientific evidence that proves that the Big Bang model is correct. We're going to examine that, and we're going to see that there's some evidence that's consistent with the Big Bang if you interpret it a certain way, but it can also be interpreted other ways. Then we're going to see that there's some evidence, scientific evidence, that actually contradicts the model. Then we're going to see that not only is there evidence that contradicts the model, the laws of science themselves contradict the Big Bang model. And in fact, not just the Big Bang model, but any attempt to explain the universe outside of a creationary framework. And lastly, we'll see that the Big Bang model actually has a severe LTT problem of its own. So, if we're going to talk about the Big Bang, we would need to define then what the Big Bang is. Well, the Big Bang model in a nutshell is that 13.8-ish billion years ago, there was a fluctuation in the vacuum of space, and a cosmic seed, if you will, popped into existence that immediately blew outwards in a massive expansion, produced energy at first, the energy condensed into matter, the matter condensed into galaxies and stars, and eventually planets formed, and here we are today looking at it all. Now this, of course, is a big topic. Can't dig into too much detail here this morning, but one of the key elements of this is that the universe is expanding, that we see an expanding universe today, and so that tells us that billions of years ago it all came from this one primordial beginning. How do we know the universe is expanding? Well, that comes from something called redshifts. So what are redshifts? Well, you may be familiar with the fact that if you shine white light through a prism, it'll break up the light into all the colors that it contains. Well, astronomers have instruments called spectrometers that are basically very sophisticated prisms. They work the same, in a similar way. And if you shine sunlight through a spectrometer, you will get a solar spectrum that looks like this. So here we see all the colors visible to the eye, except for a few colors, a few wavelengths of light that are missing. That's where those black lines are. You see these very specific wavelengths of light are not within sunlight. Why not? Well, because as light passes through the atmosphere of the sun on its way to us, specific elements in the sun's atmosphere will absorb specific wavelengths of light. And you can do this in the laboratory as well. You can shine light through gas and see what wavelengths of light get absorbed. And this is one of the ways we know what the sun is made of, because we can look at the specific patterns of absorption lines, they're called, and see what elements absorb those particular wavelengths of light. And just as a piece of scientific trivia, the element helium was actually discovered in the sun before it was discovered on Earth, because scientists were studying these absorption lines and said, well, we know what these ones are, we know what those ones are, but there's a few lines here that we don't know what is absorbing those wavelengths. And so they named this unknown element helium after Helios, the Greek sun god. And then later it was found on Earth as well. So anyway, point is, we see this pattern of lines within sunlight when it's analyzed with a spectrometer. What if you do the same thing for light from a distant galaxy? Well, you see a similar pattern of lines. So that tells us that the stars in that galaxy are made of roughly the same elements, compounds, whatever, that the sun is. Notice, however, though, that the pattern doesn't line up exactly with that from the sun. It's shifted over to the red end of the spectrum. Because it's being shifted to the red, we call this a red shift. So what is it that causes a red shift? Well, the common explanation, one of the possible explanations, and it's a good one, is that if a light source is moving away from you, the light beam will, in a sense, get stretched out. So the wavelengths get stretched out, thus shifting everything toward the red end of the spectrum. The opposite is true if the light source is moving towards you. In that sense, the light beam is kind of getting compressed, in a sense, and so the waves are bunching up, and it shifts toward the blue. And by analyzing light from different sources, we can see if it's red shifted or blue shifted. If it's red shifted, that's an indication that the object is moving away from us, whereas if it's blue shifted, it's moving toward us. Now, there are some objects that are blue shifted, and these are all local. So there are some objects locally that are moving towards the Earth. But once you start looking deep enough into space, everything becomes red shifted, and the farther out we look, the more red shifted things are. So on a broad enough scale, again, ignoring some local objects, when we look out into the universe, we see red shifts everywhere in all directions. Whether we look that way or that way, the deep space objects are moving away from us. So let's think about that. If today we see everything getting farther and farther apart, on a galactic scale anyway, the galaxies are moving farther apart. Well, if you run that movie backwards mentally, in the past, things used to be closer together. Think back far enough into time, and you reach a time when everything was at the same place. And this is the basic idea behind the Big Bang model. All the matter and energy in today's universe started out at the same place, and then began this massive expansion, and it's still expanding today, billions of years later. So this is one item of evidence that we're told shows that the Big Bang is true, and that the model is true, and that the Big Bang happened as the model says. The fact that the universe is expanding today means that it all started out at the same place billions of years ago. A second item of evidence, and I'm not going to dig too deeply into these, is that the abundance of light elements, the amount of hydrogen and helium and lithium in the universe today, matches what the Big Bang model would predict. So this again is, we are told, evidence for the Big Bang model. A third piece of evidence is that we see what's called the cosmic microwave background there's radiation coming to the Earth from all directions in space. It's microwave radiation, thus the M. And so what does this oval mean? Well, if you imagine that the Earth is here in this crude animation of a galaxy, from the Earth's perspective, we can consider that everything we see is like the Earth is within this sphere. And if you were to crack open that sphere and unwrap it, so to speak, you would get this oval picture. So when we do that for very low temperature radiation, we see that there's microwave radiation coming to Earth from all directions in space. And this is believed to be leftover radiation from the Big Bang explosion, if I can use the word explosion, billions of years ago. In fact, this was actually predicted based on the Big Bang model before it was actually discovered. And this is considered to be, in a sense, the crowning glory of the Big Bang model. It made a prediction that was then subsequently confirmed by evidence. And actually, it was this discovery that made the Big Bang model the preeminent secular cosmological model. It was not the most popular model before that discovery, but when the discovery was made, the consensus model that was competing with the Big Bang couldn't explain it, whereas the Big Bang model had predicted it. Therefore, the Big Bang model became the preeminent one among secular cosmologists. So there's three different types of evidence that's being presented to us then as proof that the Big Bang model is true. Redshifts, abundance of light elements, and the CMB. Now, indeed, you can interpret those observations as evidence, as being consistent with the Big Bang model. The claim is that they actually proved the model to be true, but that's going too far, because in reality, depending on how you interpret these observations, they're consistent with other cosmological models too. So yes, you can interpret them to be consistent with the Big Bang model, but they don't prove the Big Bang model because they can also support other models besides the Big Bang. So when someone says that the Big Bang model is proven by scientific evidence, that's not true. It's consistent with some scientific evidence, but that evidence is consistent with other competing ideas as well. And in fact, there's other pieces of evidence that aren't as often discussed that actually contradict the Big Bang model. For example, the Big Bang model predicts that the universe should be filled with what are called magnetic monopoles, particles that are magnetic but only have one pole, either north or south, but not both. The universe should be full of monopoles according to the Big Bang model, but there aren't any as far as we can see. So this is a prediction that the Big Bang made that has failed. So the lack of monopoles is scientific evidence against the Big Bang model. As for the CMB, it was indeed predicted by the model initially, but the CMB actually turns out to be very different in some important characteristics than what the Big Bang model would expect. And I'm going to return to this one later. So this is problem number 2. Problem number 3 is called the flatness problem. The energy density of the cosmos is not what you would expect from a random Big Bang. The cosmos should look one way. It actually looks a very different way in its geometry, and I'm not going into details here because it's outside of our topic. My point is that the Big Bang made a prediction which the evidence contradicts. So not only is there evidence that doesn't necessarily prove the Big Bang, there's actually evidence that actually contradicts the Big Bang model. Furthermore, this is not a question of only specific evidence. The laws of science itself discredit the Big Bang model, and in fact, not just the Big Bang model, it discredits any attempt to explain the cosmos outside of a supernatural creator. Why is that? Well, let's talk about a broader perspective beyond technical details here. Can a secular idea for the origin of the universe explain the universe in a way that's consistent with the laws of physics? Well, the answer is no. The laws of physics don't actually allow secular cosmogonies. And the cosmogony is a history of the cosmos. So if you try to construct any model that's secular, in other words, it doesn't involve a creator, and you try to explain the universe, you're going to wind up contradicting the laws of physics in one way or the other. I call this the secular dilemma. And it's based on a simple question. Just 6 words. Did the universe have a beginning? How many possible answers are there to this question? Just 2, right? Either yes, there was a beginning, or no, there was not a beginning. And if there was not a beginning, then the universe would be eternal, right? Does everyone agree those are the only two possible answers to that question? Okay. Let's look at each of these answers then and see how they're consistent. Maybe, I heard. Someone's unwilling to commit. Well, no, it's either yes or no. There was a beginning or there wasn't a beginning. Let's talk about the idea that there was a beginning. So if the universe had a beginning, and the universe is everything that exists, then everything that exists had a beginning. If everything that exists had a beginning, what existed before that beginning? Nothing, right? Because if everything began, then before that beginning, there couldn't be anything because that would be part of the everything, right? So if the universe had a beginning, then before the beginning, there was nothing. And indeed, this is part of the original Big Bang model, that there was nothing and then this seed of the universe, if you will, popped into existence. Well, I actually have a diagram, a graphic here, a picture of what everything looked like before the Big Bang. Would you like to see this picture? Nothing. So if there was actually nothing, can nothing make everything? Can nothing make anything? No. Why not? Well, because nothing can create nothing, right? Because nothing can do nothing. From nothing, nothing comes, right? Dr. R.C. Sproul once said, if there was ever once truly nothing, there could never be anything. And Dr. Phil Fernandez once said, you can't tell me nothing made everything. I know too much about nothing. So this is more of a philosophical argument, right? But it turns out physics actually has this idea built into it. There's a principle of physics called the conservation of matter and energy. It's sometimes called the first law of thermodynamics, but it's actually broader than just a thermodynamics issue. This says that the total amount of matter and energy in the universe can never be changed. You can't create it. You can't destroy it. It's always there. And you say, wait a minute, but there's examples of matter going away, or so it seems. Well, this is based on a famous equation called E equals mc squared, which you may have heard of. This tells us that matter and energy are different forms of the same basic thing. So the total amount of matter and energy in the universe is constant. You can't create any of it. You can swap back and forth between the two forms, but you can't create any of it from nothing. So, for example, we can convert matter to energy, and the most efficient way we know how to do that is a nuclear explosion. A small amount of matter turns into a large amount of energy. But we're not making the energy from nothing, right? We're converting it from the matter. We can go the opposite direction. We can take a lot of energy and convert it into a little bit of physical stuff, and we do that in particle accelerators. You get little chunks of matter zipping around at close to the speed of light, smash it together. More particles come out of the collision than went in. Not just number of particles, but the amount of physical stuff you have. But are we creating this physical stuff out of nothing? No. We're taking the kinetic energy, the energy of motion, and converting that energy into matter. So we can convert matter to energy and energy to matter, but we can never create either one from nothing because physics doesn't allow for that. In fact, if you take a physics class and you ever answer a homework problem or an exam problem in such a way that violates this principle, your answer is automatically wrong. The way that it's wrong will vary on what mistake you made, but this principle is baked into the very foundations of the laws of physics themselves. And we don't need to take a physics class to see this. I mean, we see this in our daily life. I mean, think about this. Why do we need to eat food every day? Regardless of how difficult the process might sometimes be. Because your body needs energy to operate. You can't make energy from nothing because that would violate physics. So you have to get it from the chemical energy in the food after you actually get it in your mouth. Why do you get a bill from the electric company? Well, because your appliances need energy to operate. Can't make energy from nothing because that would violate physics. So you have to get it from some external source, like coal, for example. Well, coal is chemical energy, right? Where did that come from? It didn't come from nothing because that would violate physics. That came from plant matter, which ultimately came from sunlight. Well, is the sun making energy from nothing? No, it's burning fuel and all the rest of it. We see this principle throughout our lives. In fact, you couldn't be watching the presentation here this morning if this principle weren't true, because some of the principles of circuit design are based on this principle in physics, this conservation of matter and energy, as it's called. In fact, one of my textbooks says conservation laws are the guiding principles of physics. These are absolute conservation laws. They are always obeyed. You can't create anything from nothing. Now, despite the fact that these are absolute conservation laws that are always obeyed, they're not obeyed in one place, and that's in the Big Bang model, if you're going to say that everything came from nothing. Well, physics doesn't allow everything to come from nothing. That's impossible. So we see fundamental physics then, specifically the conservation of mass energy, tells us that you can't get something from nothing, therefore the universe cannot have had a beginning. Does everyone see how that follows? And if it didn't have a beginning, therefore it must be what? Eternal. Okay, so back to our question that we're answering here. Did the universe have a beginning? We see that the answer that yes, it did, is not allowed by this principle in physics. What about the other answer? No, let's talk about that one. Does physics allow for that answer to be true? Can the universe be eternal? Well, no, it can't. And that's from a different law of physics called the second law of thermodynamics. And for this one, I like to use coffee as an illustration. So if you come into a room and there's a cup of hot coffee sitting on the counter, how long has that cup been there? Long time or short time? Short time. Why short time? Because it's still hot. It would have cooled off if it had been a long time, right? Can it have been there forever? No, because if it had been there forever, it would have cooled off forever ago, right? So we can use coffee as a crude form of clock, in a sense. The fact that the coffee is still hot tells us it hasn't been there forever. We can apply that same reasoning to the universe. Is there anything in the universe that hasn't cooled off yet? Stars, right? Wait long enough, every star will eventually burn out or explode before it burns out. Either way, it's gone, right? So if the universe was eternal, if it's always been there, stars would have burned out forever ago, and there wouldn't be any left today. But they're still there. That tells us the universe is not eternally old, right? Now, some people say, well, yeah, stars burn out, but you can still make new ones. Well, there's problems with that, but set the problems aside. Star formation itself still requires energy, of which there's a finite amount available to do that. So again, if the universe were eternally old, if it had always been there, then all the stars would have burned out forever ago, and all the energy to make new ones would have been gone forever ago, so you wouldn't have stars today. The fact that we do still have stars today means what? That the universe cannot be eternally old. Everyone see that? So the second law of thermodynamics shows that our universe has not existed forever. It's because it's not eternal, and if it's not eternal, it hasn't existed forever, it must have had what? A beginning. And by the way, I have a little note here. Christians take note. A lot of Christians endorse the Big Bang model because they think we need it to prove that the universe had a beginning, and that's consistent with Genesis, right? We don't need the Big Bang model to prove that the universe is not eternal and that it had a beginning. If you want to prove that the universe had a beginning, go outside and look up. Do you see the sun during the day? Do you see stars at night? If yes, these are daily reminders that the universe is not eternally old. And if it's not eternally old, it must have had, therefore, a beginning. So getting back to our statements about physics here, we already saw that the conservation of mass energy says the universe cannot have had a beginning. Now the second law of thermodynamics casts further light. It tells us the universe cannot be eternal, because if it were eternal, we wouldn't see stars, etc. anymore. And we already saw that the first answer to this question is not allowed by physics. Now we see that the second answer is not allowed either by physics. Anybody see a problem here? You got to pick one of the two. Maybe, yeah. If you're going to construct a secular model of where the universe came from, you have to pick one of these two answers. And simple question, 6 words. Only 2 answers. Each answer violates the laws of physics in a different way. So if you're going to make a secular model for where the universe came from, you have to pick one of the 2 options, which means you have to pick which laws of physics your model is going to violate. Either the conservation of mass energy or the second law of thermodynamics. Because one says the universe cannot have had a beginning, the other one says it must have had a beginning. One says it must be eternal, the other one says it can't be eternal. You can't build a secular model that incorporates and satisfies both of those laws simultaneously. You can't escape this trap. Now, many of these secular thinkers certainly try to do this, and this is a topic in itself. We can go through each of the proposed answers, proposed ways to get out of the trap, but none of them work. For example, Stephen Hawking used to like to say that, yes, everything came from nothing, but that's not really a problem because everything is really nothing. He said you can model the universe in such a way that it contains a certain amount of mass energy that's positive and a certain amount that's negative. You add it together, it cancels itself out. And so we're not violating physics because the Big Bang didn't actually create anything. And hopefully I don't need to explain why that is an absurd notion. Lawrence Krauss's preferred explanation is that everything came from nothing, but nothing isn't really nothing. When he says nothing, he means a vacuum of space-time that has a quantum field in it that's capable of fluctuating and making a universe. So he wrote a whole book called The Universe from Nothing, claiming that science supports this idea, but he's really redefining the meaning of the word nothing. He's not explaining where the quantum field and the vacuum of space-time came from in his proposed explanation. So a lot of people have recognized it as futile to try to get out of the something coming from nothing issue, so they will try to explain how there's always been something. And you have what are called oscillating universe models, where there's endless cycles of Big Bang, and then gravity slows it down and pulls it all back together into a big crunch, and then it rebounds into a Big Bang, crunch, bang, crunch, in this eternal cycle. Well, that doesn't work for 2 reasons. Number one, thermodynamics doesn't actually allow you to have an endless cycle of rebounds for eternity. And number 2, the Big Bang model itself isn't even consistent with this anymore, because the Big Bang model now contains dark energy, which says the expansion is accelerating. It's getting faster and faster, which means it's never going to pull together again into a crunch. If I just lost you in some of the details, that's fine, don't worry about it. My point is that all of the proposed explanations, all the proposed ways to escape this trap don't work. So any secular thinker is left with a very unpleasant choice. Which law of physics do I violate with my model? The laws of physics ultimately don't allow a consistent atheistic cosmogony, an atheistic origin of the universe. The only way to be consistent with the laws of physics in your model is to acknowledge that a supernatural creator outside of the laws of physics is responsible for the universe. We know the universe is not eternal because we still see stars, etc. Therefore, the universe had to have a beginning, but the only way to have that be consistent with physics is that a creator outside of physics did it. Does that make sense? Hopefully we're not getting lost in details here. Ultimately, there's just 3 ways to explain the fact that the universe exists. Either it was formed by a creator, or it was formed without a creator, or it never formed, because there's always been something. It's always existed. Those are your only 3 choices to explain where the universe came from, right? Well, we saw that one law of physics doesn't allow it to form by itself from nothing, and we saw that a different law of physics doesn't allow it to be eternal, so your only remaining choice is that it was formed by a creator. And I like talking about this because this is a great conversation starter if you have an acquaintance who's a skeptic. It's an inoffensive question. You're not preaching, you're not affirming something that they're going to reject out of the gate. You just ask a simple question. Did the universe have a beginning? What do you think? And they can only answer it one of 2 ways, and then whichever way they choose, you can discuss why that answer doesn't work. because neither answer works unless there was a creator outside of the universe responsible for the universe coming into being. So that's a discussion then of why the Big Bang model and any atheistic origin of the universe is not allowed by the laws of science itself. Setting aside specific evidence, just the principles that physics works according to do not permit this to happen. Getting back to our more specific topic here this morning, the Big Bang also has a whopper of a light travel time problem built into it. And this is something that is often ignored in the whole LTT discussion. And it's not that difficult to understand. You look in one direction in space and we see a galaxy. The fact that we see it means that the light reached here from there. Look in the opposite direction, we see galaxies over here too, which we're receiving light from. Now, we can see things billions of light years away. And to make the math easy, I'll say 10, although we can actually see things that are even further out than that. If we see something that's 10 billion light years away and the light is just arriving here now, and on the opposite side, the same thing is true, has the light reached from this side of the universe to that side of the universe yet? Well, if it's only reaching us and we're in the middle, then it's only halfway to its journey. How long would it take to go from here over to there? Well, you add 10 plus 10 equals 20 billion years. So the time required for light to travel across the entire universe would be 20 billion years. Actually, a bit more than that, but like I said, I'm choosing round numbers to make it easy. The problem is, from a Big Bang perspective, the universe itself is less than 14 billion years old. So if it takes 20 billion years for light to get from here to here, there hasn't been enough time for light to travel across the entire universe yet. So sometimes people say, well, okay, it can't do that today, but because the universe is expanding, then earlier in the universe's history, things used to be a lot closer together, so it could have done it then, right? Actually, no, it can't, because the math holds regardless of when you are applying it. So today, if it requires 20 billion years for light to get across the entire universe, but the universe itself is less than 14 billion, then that wouldn't work. When the universe was half of its current age, it would have taken only 10 billion years for the light to travel all the way across, but the universe itself was less than 7 billion at the time. 1/4 of its current age, only 5 billion years is required, but again, that's still more than the age of the universe itself. So hopefully you understand the point I'm making. There has never been enough time for light to travel from one edge of the universe. I shouldn't say edge, they don't think there is an edge. From one distant region of the universe all the way to the opposite side, if you will. Therefore, the Big Bang model says different regions in the universe have never been in what's called causal contact. They can never influence each other. In other words, if light hasn't traveled all the way across the universe yet, neither has anything else, because light is the fastest thing that travels, right? So if light can't travel a distance in a certain time, then neither could something like sound, for example, because sound travels more slowly than light, right? Obviously, you need an atmosphere to transmit sound, but hopefully you understand the point. The key to this whole thing, if light hasn't gone from here to here yet, because there hasn't been enough time, neither has heat. And this is the important point in all this. Because the Big Bang says different regions of the universe started out at different temperatures. And if there hasn't been enough time for heat to be exchanged across the different regions, they should still be at different temperatures. I hope everyone's still with me. This is kind of the summary right here. The Big Bang model says different regions in the universe should still be at different temperatures because there hasn't been enough time for heat to travel through the universe and equalize everything out. Because that's how things arrive at the same temperature, right? If you put an ice cube on the kitchen countertop, then you have a cold spot, represented by the ice cube, in a warmer environment, right? What happens over time? Well, some of the warmth in the room melts the ice. The ice absorbs that heat, and you wind up with a puddle of water that's at the same temperature as the room. So you start out with different temperatures at different places. After enough time has passed, you wind up with everything at the same temperature because that heat has distributed itself evenly again. The Big Bang says that things in the universe in different regions started out at different temperatures. Since there hasn't been enough time for the heat to distribute itself evenly, they should still be at different temperatures today. Here's a more practical example. If I take a bowl of water and I take ink or food coloring or something that's red and blue, and I drop it on opposite sides, put a couple drops of each in the water at opposite ends of the bowl, am I going to get purple water immediately? No. I'm assuming I don't mix it, I just leave it sit there, right? The ink or the food coloring will eventually disperse itself and mix and make purple water, but it's going to take a long time to do that, right? If someone handed you a bowl of purple water and told you that 3 seconds ago they just put drops in, you wouldn't believe them because it takes a long time for that to happen. Hopefully I'm not belaboring the point here. So the Big Bang says that different regions in the universe should be at different temperatures because there has not been enough time for all the heat to distribute itself evenly and for everything to be at the same temperature. The problem is that the universe is at the same temperature. The cosmic microwave background has been measured, and it's all the same temperature to within 1,000th of a degree everywhere. This is called the horizon problem. The universe is all at the same temperature, but the Big Bang model says there hasn't been enough time for that to happen. Heat, and therefore light, has somehow traveled through the whole universe, even though the Big Bang model says there hasn't been enough time for that to happen. So the Big Bang model has a light travel time problem of its own then. Someone pointing the finger at you, if he believes in the Big Bang, can't be doing that because his model has the same problem that he claims yours does. Are the Big Bang modelers aware of this? Well, yes, they are, most certainly. Their proposed solution is something called inflation, where when the universe first popped into existence, it instantly inflated at multiple times the speed of light in a very short period of time. And for various reasons, this allows the temperature to have been more even in the beginning and therefore would still be today. So cosmic inflation, this universe popping into existence and then blowing itself up at multiple times the speed of light, supposedly solves the LTT problem for the Big Bang model. But that just changes the problem to a different question. What is inflation? What process in physics allows this to happen? Well, it turns out no known process in physics allows this to happen. Inflation is outside of known physics. As this quote says, what drove inflation? Well, nobody knows. Physicists have suggested different models to describe the inflating universe, but all the solutions are mathematical conveniences with no particular physical basis. In other words, no basis in physics. This astrophysicist said, all the theories of inflation amount to proof that we don't have one good theory yet. We don't have one good theory yet. This other author points out that the inflationary model, originally introduced by Alan Guth in 1981, was designed to solve the horizon flatness and entropy problems. Since then, we are faced now with more than 200 inflationary models. If you have 200 models for something, are any of them any good? Do we need 200 models for gravity? No, we have one model for gravity because we know how gravity works. Do we have 200 models for how an ice cube melts into water? No, we know how that process works too. When you have something in physics where there's 200 models being suggested, it tells you none of them are any good, because if one of them was good, then the majority of people would be attracted to it, right? Moreover, as this idea has been contrasted with data coming in, it's actually getting worse for the secular cosmologists instead of better. This physicist points out that the model itself, when compared to current data coming from studies, is exponentially unlikely according to the logic of the paradigm itself. So the mathematics of the model actually says the process that it's claiming to explain is exponentially unlikely. So what do you call it when you need a process that's outside of physics and that the mathematics of your model itself says it's exponentially unlikely to happen? That's called a miracle. So in order to solve the Big Bang's LTT problem, you have to invoke a miracle. Well, now we're moving outside of what science is supposed to be, right? Now, I don't personally have a problem invoking a miracle to explain the origin of the universe, because that's how the universe got here. That's the only way consistent with physics. But the secular folks are claiming to reject miracles while still requiring one in their model. So we see then that the assumption that the Big Bang is a valid model and that biblical creation is not valid. The LTT challengers believe that they have a solid foundation to make this accusation from, but they do not. Now, that was the longest of the things I'll be talking about this morning, but I want to spend some time on it because it's a part of the debate that is never brought up. Before someone can point fingers at us, they need to make sure that the finger can't be pointed at themselves as well. Okay, what about these other assumptions? The LTT challenge is based on the assumption that the speed of light is constant through space. Going back to this equation that we talked about, we already said that the speed, if it were different in history, would change this issue, right? It would change the calculation. Well, what if the speed of light didn't change through history, but what if it does change through space? Because think about it, where have we measured the speed of light? It's always been in laboratories on Earth, right? Now, we've had a few spacecraft in the solar system as well that we can make observations with. But basically, all of our observations are within the solar system, within the gravitational field of our sun. What if gravity affects the speed of light? Would we be able to measure that? No, because we've always been within the gravitational influence of our sun, and beyond that, within our galaxy. What about elsewhere? What about deep intergalactic space, where light can travel for long distances without passing by gravitational fields of stars and galaxies and so on? What would the speed of light be there? We don't know. We have no way of measuring it. Nor do we have hopes of doing so in the foreseeable future. Now, everyone assumes that it's the same out there as it is here within our galaxy, within our solar system, but that's just an assumption. Maybe in deep space, the speed of light is different. If so, that would drastically change the whole LTT calculation, right? And this isn't some crackpot idea either. There are some secular cosmologists who are investigating what are called variable speed of light models, trying to figure out how or if it's possible for light to travel at different speeds through deep space. Now, they're not doing it because they're trying to support biblical creation. They're trying to eliminate the horizon problem for the Big Bang model. But my point is, there are some mainstream scientists who are looking into this idea as well. So that's an assumption built into the LTT calculation, that the speed of light has been constant not only through history, but also throughout space. So by questioning that assumption, that opens up a possible solution to this issue. Assumption 3 is that light has always traveled the entire distance. Back to our calculation, now we're not talking about speed anymore. Now we're going to question the distance that the calculation is based on. When we look out into space, we see all these objects that are far away. The LTT challenge assumes that the light left that object and traveled all the way here. What if that weren't true? Given that we affirm creation, well, what if part of the creation process was creating light beams in place from there to here? Like we talked about in the beginning, right? At the beginning of the talk here. Did Adam see any stars when he first woke up at night? Presumably, even though the first one would still take 4 years for the light to get here from there, more than 4 years. Well, apparently that light got here somehow. What if the Lord just created the light beam in place for him to see? Because if the heavens are to declare the glory of God, shouldn't they be doing it right away? This idea is part of a larger concept called mature creation. Now, the Lord had to create the earth mature in a lot of different ways, right? In order for it to be functional. I mean, did Adam and Eve have to wait 3 to 4 years before the fruit trees grew up and got mature enough to produce fruit for them to eat? Well, no, they had food right away. They had mature trees, they had mature plants. Apparently the Lord created everything in such a way that it's mature in some respects. Well, why do we limit that thinking only to the earth? Why not say the whole cosmos was mature, including beams of light, so that we could perceive these things in the heavens to glorify him through? Now today, things are starting to catch up, right? I mean, the fruit trees we see today were not created mature. They grew from pits and seeds and whatever in the normal way. In the very beginning, they were mature, and subsequently natural processes have overtaken that. Different things, though, have different time cycles for that catch-up process to happen. And starlight would be an issue that would take a long time for that process to catch up, so to speak. Am I explaining this well? Okay, I get a few nods. That's good. Now, some people don't like this idea, even some people in the creation community, because they say, well, that means, though, that the things we observe in space aren't real, because we're seeing a light beam that God created showing us something that in some cases never actually existed. Here's an example of that. In 1987, we saw a star blow up in what's now been named supernova 1987A. This object was apparently 168,000 light years from us, greater than 6,000 light years at least. So we saw a star there, whereas today we see the expanding remnants of a supernova. If the mature creation idea is true, the star never existed. Because there's this light beam here that roughly 6,000 years ago, let's say, again, we don't know exactly when creation happened, but let's call it 6,000 years ago. So 6,000 years ago, according to mature creation, the Lord created this light beam coming to Earth. The first 6,000 light years of it, almost, contained the image of a star. Then at one point, it contained the image of a supernova, and then back here, there's images of expanding supernova remnant. So now we'll go forward in time. Now this is what it looked like during creation. Over a few thousand years, we're starting to consume the light beam, so to speak, right? We still saw the star for several thousand years, but then in 1987, we reached the end of the image of the star, and instead we saw the image of a supernova, and now that's what we're seeing from here. So do you see the philosophical objection then to this idea? Some people say, well, I don't like this because this means that we saw a star that never actually existed back here. It was just built into the light beam that the Lord created. Now, so they say the Lord would be deceptive if he had done things this way. Now, personally, I don't think that. Was Adam deceived by waking up next to mature fruit trees? Well, no, because the Lord told him, I just made this. So it may look mature to you, but by telling Adam when it was all formed, Adam could know. So since we already say that mature creation must have applied to the earth in some regards, then why not say that it applies to starlight as well? In fact, mature creation, the idea of the Lord creating functional light beams in place, would have to apply to at least one star, and that's our sun. If our understanding of astrophysics is correct, it takes several thousand years for light generated inside the sun to work its way out to the surface. Now, once it reaches the surface, it then zips to Earth at the speed of light and takes a little over 8 minutes to get here. But it takes thousands of years to work its way out to do that. If the Lord had not created the light at different stages of maturity, in a sense, then we wouldn't, Adam certainly would not have seen the sun. But he did. So the Lord had to create functional light beams for at least one star, the sun. Why not the rest as well? So by questioning that assumption, we see that opens up a possible solution to the LTT problem. And I hope you're seeing I'm not endorsing any one of these as a specific solution. I'm saying there's different types of solutions depending on which assumption you want to challenge. And that's, to me, the most important part of this, the fact that there are assumptions. And assumption 4 is that light has always traveled as it does today. What do I mean by that? Well, now we're back to questioning the speed. Dr. Danny Faulkner who has at least one book and DVD on the table back there available, PhD astronomer, physicist, and Bible-believing Christian. Notice that Genesis has some interesting choice of words in some places. Like Genesis 1:11 through 12 says, God said, let the earth bring forth grass, herb-yielding seed, and the fruit tree, and the earth brought forth these things. Did the Lord say, let there be grass, and zap there was grass, and zap there was fruit trees, and zap there was vegetation? It doesn't say that in the Hebrew. There's a different word there, brought forth. The word in Hebrew is called dasha, and Dr. Faulkner refers to this as the dasha cosmology. He said it appears that on day 3, the Lord didn't say, zap, 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 here's plants. Instead, he said, let the earth bring forth these things, and that's what the earth did. It sounds like an accelerated process, doesn't it? Like fruit trees grew like fruit trees normally do, but they did them in one day rather than taking several years. So his argument is, if Creation Week included these accelerated processes here on Earth, what if that applies to Starlight as well? What if the Lord supernaturally accelerated the Starlight on the way here? Would that explain how the Starlight got here? Well, of course it would. Now, some people don't like this idea because it's explicitly miraculous. Well, so is the universe. We already saw that you can't explain the existence of the universe in a way that's consistent with the laws of physics unless it was supernaturally done. And we affirm that creation is a supernatural event at the very beginning, right? And you look far enough back in time, you can't use physics to explain it all the way back. At some point, you have to start invoking a miracle. And why not here? This works just as well. And it would indeed solve the LTT problem in a way that's consistent with the biblical text. Last assumption that we'll be talking about, that the universe has no center of mass. Now we're not going to question distance or speed. Now we're going to question time. We've already talked about redshifts in the sky, the objects we see in the sky, and how they apparently represent motion, that these objects are moving away from us, and that we see them in all directions. Now, this is commonly understood to be evidence that the universe is expanding, and if it's still expanding today, it used to be much smaller in the past. Well, there's two possible ways to interpret the redshifts that we see. I told you that we see things moving away from us in all directions. We appear to be at the center of the expansion. Now, there's two ways to look at that. Number one, we appear to be at the center of the expanding universe because it would look that way from anywhere in the universe. Regardless of where you were, you would see everything moving away from you in all directions. That's one possible interpretation. And this is how the Big Bang model answers this question. It uses that interpretation. But it's not the only possible interpretation. The other one is that we appear to be at the center of an expanding universe because we are at the center of an expanding universe. Now, this is not the interpretation used by the Big Bang model. And part of that is because of an emotional reaction that people have to the idea. For example, Edwin Hubble was one of the first secular thinkers to wrestle with this. He realized, as have many others, that if we're at the center of the universe, that puts us in a pretty special place, right? If we're at a special place, what would that imply we are? Special. You don't get at the center of the universe by random events, right? Well, as Edwin Hubble said, the supposition that there's a favored location is very, unwelcome. It must be avoided at all costs. A favored position, of course, is intolerable. Is that a scientific statement? No, it's an emotional reaction. Therefore, in order to restore homogeneity and to escape the horror of a unique position, the departures from uniformity must be compensated. There seems to be no other escape. If we see the nebulae, galaxies and such, at his time it wasn't fully understood what they were, they're all receding from our position in space, everything's moving away from us in all directions, then every other observer, no matter where he's located, will see the same thing. However, the assumption is adopted. There must be no favored location in the universe, no center, no boundary. Everybody must see the universe alike. This is called the cosmological or the Copernican principle, the idea that the universe cannot have a center. And this is actually built into the Big Bang model itself. The Big Bang model ultimately rests on three things foundationally. We see the redshifts in the sky we applied the mathematics of general relativity to figure out how it all worked itself out, but you can't apply relativity until you decide if there's a center or not, because the math is different either way. The Big Bang modelers assume that there was no center, and that assumption is called the cosmological principle. So ultimately, these three things are the foundation of the Big Bang model. We see redshifts, we make an assumption that there can be no center, and that allows us to apply relativity in a certain way and produces the Big Bang model. Note, incidentally, Christians who affirm the Big Bang model are affirming a model built on a principle that is implicitly a rejection of God, right? A lot of people don't realize this. The Big Bang has an anti-theistic assumption built into its foundational reasoning. And again, this is an assumption. It's not an observation. It's an assumption. And apparently it's an invalid assumption because the Big Bang model is incorrect. Let's talk about logic for just a moment. If you have valid logic and valid assumptions, you'll reach a valid conclusion, right? So all men are mortal. Socrates is a man. Therefore, Socrates is mortal. That's valid logic based on valid assumptions, therefore reaches a valid conclusion. Is this valid logic, though? All men are fish. Socrates is a man, therefore Socrates is a fish. The logical reasoning is valid, but the conclusion is invalid, which means what? One of your assumptions was invalid. Why am I talking about this? Well, because if the conclusion, the Big Bang model, is incorrect, that tells you one of your foundational things must be incorrect. Well, the redshifts, that's just data. General relativity, well-supported, well-understood laws of physics, what does that leave to be incorrect? The cosmological principle. So I would argue that the better assumption for how to interpret this expanding universe is not the first one, that there is no center and so you'd see that regardless of where you were. I would argue the better interpretation is that we appear to be at the center of an expanding universe because we are at the center of an expanding universe. And if there's a center, there can be a center of mass. And that opens up a really interesting possibility. If there's a center of mass, you can have what's called time dilation, where time flows differently depending on the distribution of mass and depending on your location relative to the mass. Because it turns out, this is predicted by relativity and confirmed by evidence, gravity affects time. The more gravity you are experiencing, the slower time flows for you. Now, this is not a big effect on something like the Earth, and so we don't notice it in our daily lives. We can, however, measure it in certain respects. For example, atomic cesium clocks, there's a number of them in the world. We have a couple in this country, and when you compare the one at sea level in Maryland versus the one almost roughly a mile above sea level in Colorado, the one at sea level ticks a little more slowly than the one a mile above sea level. Now, an atomic clock doesn't tick, but you don't understand what I'm saying. Time flows more slowly down at sea level because you're deeper in the Earth's gravitational well compared to being a mile out of it in the mountains of Colorado. In fact, the GPS satellites, which I'm showing you here, I got to work on this program for a while, and the design documents were actually pretty interesting. The engineers who designed GPS had to compensate for this because GPS is based on a very precise calibration of different clocks. And time flows more quickly in orbit, where the GPS satellites are, than it does for observers down on Earth with our cell phones and our GPS devices. So GPS actually has to compensate for this relativistic time difference between how quickly time flows for them versus it flows a little more slowly for us down on the surface. Now, it's not much, but it does have to take this into account. So why am I talking about this? Well, because in multiple places in the Bible, it says the Lord created the heavens and then stretched them out. So what if today's universe is still expanding, right? Or at least there's evidence of past expansion. Imagine all the stuff we see in the universe today in a much smaller volume. So the Lord created everything in a small volume and then began to stretch it out. What would that look like? Well, if the volume were small enough, if everything was packed into a small enough amount of space, you could have had a black hole. So now the Bible doesn't say this, of course, but we're just talking possibilities. What if the Lord had created everything in a small enough volume to be in a black hole? Well, a black hole has something called an event horizon, represented by the dotted line here. That's the boundary of the black hole. Now, it's not a physical boundary, it's just a distance. Within this distance of the center is where all the black hole weirdness happens. And black holes do have some weird physics. Now the Lord starts to stretch everything out. As the volume increases, the event horizon starts to shrink. The black hole gets smaller. Now he starts forming inside of this matter, stars and galaxies and so on. But everything is still inside the black hole at this point. He continues stretching. As the universe gets bigger and the black hole gets smaller, now some of the stuff in the universe is outside the black hole where the rest of it is still inside. And this is where it gets interesting. In this idea, the Earth is still inside because we're at roughly the center of all this. Time flows differently outside a black hole than inside. You could even argue that the time effectively stops inside of a black hole. So time is now flowing out here, but hardly at all inside. The Lord continues stretching. Again, more time is passing outside, whereas we're still inside the black hole. As the Lord continues stretching, eventually the universe gets large enough where the black hole shrinks and goes away. At this point, time flows uniformly and equally throughout the whole universe for the first time, and has been doing that since then, other than local distortions if you're next to a star or a planet or something. But what happened before this? A lot of time passed out here, whereas no time passed here. And what perspective is Genesis written from? It's from the perspective of the Earth, right? It's telling you what's happening on the Earth. The physicist who first realized that all this was possible because of time dilation, if you ask him how old the universe is, he'll say, according to which clock? Because a clock out here could have measured billions of years, whereas a clock on Earth could have measured a day or two. Which clocks are correct? Well, they all are. They all accurately measure time according to their local environment. But that gives time for galaxies to collide and other things we see in space that would seem to require some time. It gives time for light to get from there to here, while meanwhile on Earth, only a couple of 24-hour days have passed. Anyone see that? Now, the physicist who first came up with this idea has actually, this is not his current model. He's added more things to it since then, but that takes quite a lot longer to explain. I like talking about this because it illustrates the basic idea. Depending on how the mass in the early universe was organized, time can flow differently at different places in the cosmos. So you can have time pass way out there and have time for light to come here, while an observer on Earth, his clock or her clock would still be reflecting very little time having passed. And since that's the perspective that Genesis is written from, this doesn't violate what the biblical text says. So assumption number 5 that the LTT challenger makes is that the universe has no center of mass, because if he believes in the Big Bang, that's how he thinks. But if you acknowledge that it can have a center of mass, that opens up this whole set of models showing how time dilation could have light traveling the whole distance from out there to here, while still very little time passed here on Earth. So my time here this morning, I went through these 5 assumptions. There's actually more than 5 built into this question. But I've already consumed my entire time. So distant starlight, does it disprove biblical creation? Hopefully I've made the point this morning that this issue is a lot more deeper and richer than it's commonly thought to be. There's a lot of assumptions built into that question. Questioning each assumption opens up a different possible solution. So what do the heavens declare anyway? Not the Big Bang model. The heavens declare the glory of God. And starlight is only one way in which we can perceive that. So I presented a perspective on astronomy that is obviously not mainstream. If you like this kind of thing, I have an email newsletter available on my website, which is creationastronomy.com. If anybody here is on the list, you will know that you don't get spammed. You hardly get anything, actually. Something I'm trying to rectify. More is coming, I promise you that. In the table and back, there's several DVDs available. I have a 3 DVD set on astronomy. If you like this kind of perspective on things, there's more available here. Volume 1 talks about our solar system. Where do the various planets and other objects within it come from? Did they form from a cloud of gas billions of years ago, or is there evidence that that's not the case? Volume 2 focuses on stars and galaxies. What do we know about star formation, galaxy formation? What do they tell us about the Creator? Can the secular model explain those things? And a lot of the material here this morning, specifically the Big Bang stuff, was actually taken from Volume 3, which is a deeper dive into the Big Bang model itself, showing that laws of physics don't allow the Big Bang model to have happened in the way that it's presented, that you need a supernatural creator to explain the universe. Again, there's my site. I thank you very much for the opportunity to speak to you here this morning. I know I went pretty quickly and I covered a lot of things. Hopefully this has been helpful. Thank you.
Thank you, Spike.